Hi everyone! I saw this post from an engineering memes Facebook group where I am, by the way, one of the top contributors. What? I love memes! Well, basically, this guy is asking for help on how to calculate the equivalent resistance of the circuit that was given to them. When I see mad problems on the internet, I can't resist the urge to challenge myself to solve it. And there's an idea that popped into my head. What if I create a video series about solving circuit problems? That's why this is Circuit Analysis 101. But before that, a segue to our sponsor, PCBWay, my trusted PCB manufacturer for project making. Now, here's the question. Determine the equivalent resistance for the given circuit. If each resistor is equal to 9 ohms, what is the equivalent resistance from point A to point B? The first thing that you need to remember whenever you are about to analyze a circuit, especially when you are about to determine the equivalent resistance, remember to use what I call the break it down method. We'll break down the circuit piece by piece, determining equivalent resistances until we have a single equivalent resistance for the entire circuit. What are we waiting for? Let's break it down. Step 1. We'll begin by redrawing the circuit to make series and parallel connections readily apparent. We'll label this redraw as first redraw because there will be several redraws throughout the process. In this case, the primary concept behind our first redraw is to simplify the series connections by combining their resistance to calculate an equivalent resistance. In this case, we have a series connection. For series connections, we simply add their resistances. For this first side, 9 ohms plus 9 ohms equals to 18 ohms. Apply the same process to all the remaining sides. Step 2. Label this as the second redraw. Simplify the parallel connections using the equation R3 equals to open parenthesis 1 over R1 plus 1 over R2 plus 1 over Rn close parenthesis raised to negative 1 to get an equivalent resistance. In this case, calculate open parenthesis 18 raised to negative 1 plus 9 raised to negative 1 close parenthesis raised to negative 1, which equals 6 ohms. Apply the same process to all the remaining sides. Steps 3 and 4. Label this as the third redraw. Repeat steps 2 and 3 until the circuit has been simplified to a single equivalent resistance. In this case, the sum of 6 ohms plus 6 ohms equals to 12 ohms. Follow the same procedure for the remaining sides. Now, for the fourth redraw, all you have to do is to calculate these parallel connections. In this case, the calculation will be open parenthesis 12 raised to negative 1 plus 12 raised to negative 1 close parenthesis raised to negative 1, resulting in 6 ohms. Therefore, the equivalent resistance from point A to point B is 6 ohms. To verify our answer, we will be using Multisim software. And there we have it. We got the correct answer. Keep in mind that in step 2, the equation should be R3 equals to open parenthesis 1 over R1 plus 1 over R2 plus 1 over Rn close parenthesis raised to negative 1. Here, R3 stands for the combined resistance of the parallel connections, and R1, R2, and Rn represent the resistance of each separate parallel branch. Overall, make sure to double check your calculations and use the correct equations for each step to ensure accurate analysis of the circuit. And as always, keep learning and have fun. Bye!